Welcome to this video. If you are new to this channel, remember to hit the subscribe button. So in this video we're going to look at limits, and we're looking at epsilon delta proof. Now we have this question here which says use the definition of the limit to show that the limit of that function 2x minus 5 as x approaches 4 is equal to what? To 3. So one can say that that limit is obvious, since when we write that function there 2x minus 5, then we replace 4 where x is, we have that 8 minus 5 is just equal to what? To 3. So somebody would say, no, of course it's obvious that the limit is what? Is 3. But we are told in the question use the definition of the limit to show that that is what is true. So how do we do that? So we must first understand the definition of the limit itself. So we will start from there. Okay, so what is a limit? Now, we say that the limit f of x, we say that the limit of the function f of x as x approaches a is L. Yeah, we say the limit of f of x as x approaches a is what? Is L, and is written in the form the limit as x approaches a of f of x is equal to what? To the limit L. So L is what? Is the limit. So if this is true, then we know that L is what? Is the limit. So now what is the exact definition of this? So the definition is we're using the epsilon delta proof. So meaning in the definition we must have the epsilon delta in the what? In the definition. So the definition says for every epsilon greater than 0, so I will use some notations here. Let me use some notations here. I will write in this way. So this symbol here, more of an inverted A, means for all or for every. For all or for every. So for all epsilon greater than 0, then there exists a delta greater than 0 such that if okay, so I have a statement that follows here: x minus a is less than what? Delta. So 0 being less than modulus of x minus a less than delta. So such that this then implies that modulus of f of x, which is the function, minus L, which is the limit, modulus, so this is in a modulus, then this will be less than epsilon. So that is the what exact definition of limit. So if I say my limit exists as I wrote in the first part here, or how we write a limit, we would say for every epsilon, no matter how small epsilon is, as long as epsilon is greater than 0, there will exist a corresponding delta also greater than 0 such that this statement here that follows is true. Then if that is there, then we will have f of x minus the limit less than what? Delta. So if this here is true, then I will have modulus of f of x, which is my function, minus my limit is going to be less than what? That epsilon. So when you're proving this, in short, you want to show that this epsilon actually what exists. Like you have an epsilon, like your end goal is to get an epsilon, just to get what? An epsilon alone. Then you would have shown that what? That is true. So now, how are we going to do that? Let us use the question which we have been given. Let us use the question which we have been given, and from the definition which we are just from writing, we will use it in order to find our solution for that question. So how do we do that? Okay, let me erase this part. Okay, so okay, so my limit in this case, that which we are showing, is this one. Let me write it as x approaches 4 of 2x minus 5 is equal to what? To 3. So let us use the definition now. So from the definition, we'll say for all epsilon greater than 0, then there exists. So this inverted e or backwards e means there exists. So for every epsilon greater than 0, there exists a delta greater than 0 such that if I have 0 less than modulus of x minus, where my a, in this case, that's where the limit is going or approaching, which is 4. So it's approaching 4. Modulus has to be less than that delta. So if this is there, then it means modulus of f of x. What is my f of x in this case? So my f of x is 2x minus 5 minus my limit. So what is my limit? My limit is 3 modulus, then this is less than what? Epsilon. So we're saying for all epsilon greater than 0, there must exist a delta. So in short, we must find, or we must have a starting point where epsilon is involved. Then we must what? Find a delta, and we must use that delta such that we remain with epsilon alone. So how do we do that? So now when we look at how this is phrased, we see that this part here is the one having what? The epsilon. So we'll start from there. So we will write modulus of 2x minus 5. I close my bracket there. Then I have 3 modulus less than epsilon. Okay, what do I do? So I can expand this. I'll have 2x. So minus 5 minus 3, I get minus 8. This modulus less than epsilon. So now from there, what do? I can factor out here. I can factor out a 2, and I'll have x minus 4, just like that, less than epsilon. So from this since this is multiplication here, 2 is multiplying throughout with all this, and by the rules of modulus, I can move my 2 outside there, and I will be left with x minus 4 in the modulus there. Then that will be less than epsilon. So now I can see that here I have 2, and I can divide throughout by what? By 2. So I have a modulus of x minus 4 going to be less than epsilon divided by 2. Now, this part here, the first part where I have modulus of x minus 4, I can see from what I defined here that this part is less than what? Than delta. So when you reach this stage here, what you must do is you must choose a delta that must what? Must work. So you will say I choose. So you say I choose delta. I choose delta to be. So I see that this is less than. So here down here we have that modulus of x minus 4 is less than epsilon divided by 2. Then I know here from the top what the statement that I had written, that modulus of x minus 4 is less than what? Delta. So meaning this could be replaced with what? Delta. Then meaning my delta, I will choose my delta to be epsilon over what? Over 2. So choose my delta to be epsilon over 2. So from here, what I do next is I must show that the delta which I have picked, which is epsilon over 2, works. I must show that this works. So how do I show that this works? So I will start from this point, but this point here where we started from, but I will leave out the epsilon in this case. So how do we go from there? So I write that there. I have 2x minus 5 like this minus 3 modulus. So this is going to be equal to, so when I expand that, I know I will get 2x minus 8 like that. Then from here, from there, I know that if I factored out my 2, and by modulus my 2 would come out, and I would remain with x minus 4 as we did before. Now, from here, I know that this part here is less than what? Is less than delta, from the assumption made here from on top, or from this statement on top here. It is less than what? Than delta. So meaning that this here 2 will be less than, so this will be less than 2 to what? Delta. Since this part is less than what? Than delta. That will be 2 less than 2 delta. So now I chose my delta to be epsilon over 2. So meaning that will be equal to 2. Then I have my delta is epsilon over 2 like that. So here my 2 and my 2 divide, then I will have only our epsilon remaining, which is what we wanted, that we should remain with epsilon. So this is how we solve that question, and this is how we use the exact definition of a limit in order to find, or in order to show that the limit exists. Thank you for watching this video. If you're new, remember again to hit that subscribe button and like and share this video. See you in the next one.